stratified sampling, which is a kind of restricted sampling. Now, in a stratified sampling, the universe or the population, okay, is subdivided or divided into groups or stratified, or it can be called as strata, which are mutually exclusive and include all the items in the universe or population. And after dividing into groups or strata, a simple random sample is chosen independently from each group. That is, we are going to apply simple random sampling into each group or strata for the final selection of our required sample. Now, how to select a stratified random sample? First of all, if you have a population, you will have to divide it into groups or strata in a way which will minimize the differences among the sampling units within the strata and maximize the difference among the strata or between the strata. Okay, that is, you have to divide the groups or strata in such a way that each group has a peculiar characteristics or behavior, such that these groups, within the group, it should be homogeneous in characteristics or behavior or whatever aspects may be, but among the group or between the group, okay, it should be heterogeneous. You should maximize the difference there. Now, the number of strata should not exceed 6. Okay, that is, it should be less than 6, and that would be a more desirable number of strata or groups that you should from any population. Now, the sample size within the strata. Now we have to, after grouping the population, or after dividing the population into a certain number of strata or groups, what we should do is we should take a sample size, or we should have a sample, and for that, from each group we should choose or select some units. Now for that we can use proportional allocation or disproportional allocation. Now let's see what is proportional allocation. Now in this example you can see that there are 12 individuals, and this 12 individuals constitute my population. Okay, so this is my population, and what I did is I divided them into 4 groups. 4 groups consisting of 3 members each. Now if you closely observe, you can see that in each group I have divided the group, or I have divided the population in such a way that they all are dressed up in what? Same color. Okay, so in the first case it is blue, second it is green, third pink, and the last one it's orange. Fine. So so this is one of the aspects that I have taken into consideration, and the population now here is divided into 4 groups. Now the next step I'm going to apply is to apply simple random sampling in 4 groups, and I'm going to pick one from each group so that I get a sample size of 4. And see, before this experiment I have already made up my mind that I only need 4 as my sample size, so I took one from each group. So it was easy for me to to create a sample. It is not, if you closely observe the sample also, you can see that it is a representative sample, because from each group I have taken one. Okay, and I hope it is fine with you also. So I have picked them by using a simple random method. That is, in the blue group, what I did is I applied the simple random method. I might have used lottery method or the random number table method. Now in this case, a lottery method is enough. You don't have to use the tables. Okay, so that is how I picked each person's. Now let's see another case. Now in this case we have the population as 9. Now I have divided them into 3 groups based upon, again based upon what they what the dress they wear, and the color also. So what I did is I again applied the simple random sample to each group, and I got my desired sample. Okay, so my sample right now consists of 3 persons, and I took one from here, one from here, one from here, using the lottery method. Okay, now let's see another example. Now in the last previous 2 examples, you have noticed that when I divided the population into certain groups or strata, each group had 3 members, right? So equal number of members were there. But in this case, if you closely observe the population, the blue team has only 1, 2, 3, 4, 5, and 6, and the beige, or whatever you say it, for me it's beige, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay, so here you have 9 members, and in the blue team you have only 6 members. Now here it is not equal. The number of units or number of individuals in each group is not the same. Both the groups are not the same. But what I did is, I don't have any other options, so what I did is I divided them into 2 groups based upon what they were. And what I did is I selected from each group, and by using the simple random sampling method, and from the blue team I selected 3 members, and from the beige team I selected 1 member. Now, do you think that this sample, what I selected from this particular population, is this a representative sample? No, right? Why? Because in this population you have only 6 blue units, and out of the 6 you selected 3. Whereas the case of the beige group, you have 9 members but you only selected 1. So if I implement a study in this particular sample group, will the outcomes, or will the result will be reliable? No, because I will only be able to hear the voices of the blue team, whereas the beige, I only have one particular person over here, and that is not enough. So this is not a representative sample of this population. So what will we do if we get a population like this? And in real life situation, it is almost a sure case that you will get a population which, as you see over here. Okay, there would be different characteristics. So when you divide, the number of people in a particular characteristic A will not be equal to the number of people in a characteristic B, those who possess characteristic B. So many of the times this is the kind of data, or this is the kind of population that we get. So it is not easy to pick a sample from here which will be a representative sample. If you do not apply techniques, if you do not apply statistical techniques over here, see, this is the result. Okay, you won't get a representative sample. So let's see what we can do in order to find a representative sample. Now, in this case, you just observe the image. Now you can see here you have 12 numbers or 12 units. It might be 12 individuals as well. So anyways, now this 12 is your capital N, that is the population. And I'm planning to take a sample from this population which has a size 4. Now what is the first thing that I do if I'm using a stratified random sampling? Yes, you have to divide the population into groups or strata based upon the characteristics of behavior or any characteristics that is possessed by that particular individual or unit. Okay, so now here I am grouping them based on their team color. Now this is team blue, this is team red, and this is team green. Now in team blue and team green, you can see that there are only 3 members, whereas in red there are 6 members. Now the number of members in each group or each strata are not the same. Okay, so just in a table you write down the team and the frequency or the number of members in each team. Fine. Now what you have to do is you have to select individuals or units from each group. But in what way? Okay, in what way? What is the criteria? Or what is that what is that equation, or what is that mathematical function or technical function that you have to use so that you get a sample, you get a representative sample. Okay, so see, as I said, I need a sample of size 4 and my population is 12. Fine. So let's have a look at the blue team. I need someone from blue team, right? So I'm going to use a simple random sampling method. But I do have a confusion that by using a simple random sampling method also, how many members should I pick from blue team? So that was my confusion. So what I did is I took this proportion. Now, how do I take the proportion? This is something that you have studied in your higher secondary classes. So what I did is, now you know the population is 12 and your desired random size, the sample size is 4. So what I did is I multiplied 4 into the proportion of the blue team with respect to the population. So 4 multiplied by 3 divided by 12, which is equal to 1. Now I can take one unit from any one unit from this blue team. So here I'm going to apply a lottery method. Again, what I do is I just write all the names, that is 1, 10 and 12 in 3 chits. I put it in a bowl, shuffle it. I take one chit, and when I take the one chit, I got it as 10, and that unit or that person is selected in my sample. Okay, similarly I do the same procedure in the red team. Now the red team, you have members as 6. So what I do is my desired sample size is 4. So 4 into the proportion of red with respect to the population, that is 6 divided by 12, which is equal to 4 into 6 divided by 12, which is equal to 2. So I take 2 units from red, 2 units, or it could be 2 individuals. So that was again by using the lottery method. Lottery method in the sense it is the simple random method or simple random sampling method. So you take 2 and 8, you get 2 and 8 from them, from the red team. Similarly, the same procedure is conducted in the green team and you get 5. Okay, now you have a desired sample, and now the sample is a representative sample of the population. So this kind of sampling, using stratified sampling and using proportional allocation. Now when you do these two things correctly, you will get a representative sample. Okay, fine. Now we will move on to what is disproportional allocation. Now disproportional allocation is very easy. There is nothing much to think about. What you have to do is you have to take equal number of cases are taken from each strata regardless of how strata is represented. That means we do not consider the the number of members in each group. Okay, we do not consider the number of members in each group, or we do not consider the proportion of each group with regard to your population. What we do is, instead of, if you have a sample size of 3, if you have 3 groups, what you do is you take one member from each group. Okay, so from the first group you will take one, from the second group also you will take one, from the third group also you take one. So equal number of units are selected from each group. Okay, so that is disproportional allocation. Now let's move on to the merits and demerits of stratified random sampling. So merits are like they are more representative, as you can see, greater accuracy, greater geographical concentration. So these are some of the merits. Now demerits are that you should take utmost care while performing this stratified random sampling. As you know that you need some technical skills for it, so you need skilled sampling supervisors, and hence more cost is involved. Now let's move on to systematic sampling. So what is systematic sampling? Systematic sampling is formed by, or this method is nothing but selecting of one unit at random and then selecting additional units at evenly spaced intervals until the sample has formed. Now if I say like this, I know some of you might not understand, so we will move on to an example and the procedure so that you will get a clear picture of what systematic sampling is. Now the procedure is as follows. You will have a statistical investigator. Now what you will do is you will give him a complete list of the population, and the investigator, what he does is, the list what he gets, he might arrange the list in an alphabetical order, geographical order, or any other order according to his convenience. After arranging that in a particular format or particular order, the items are serially numbered. Okay, like 1, 2, 3, etc. Then the first item from the population is chosen at random, and he uses a lottery method there. Okay, so there, if there are 100 people, what he do is he write down the names, and then he chooses one randomly, one sheet randomly, and if he is lucky enough, or he will might get 3 or 4, and what he do is the subsequent items are selected by taking the kth item. Okay, now first he will draw one item at random, and the next item what he do is he select the kth item. Now how to find that kth item, how to find that particular ratio or the interval at which he has to collect the data, that is what we have to check right now. Okay, so how do we get the k? K is equal to capital N. If 100 is your population size, then if your desired sample, if you're planning to take a sample size of 10, 100 divided by 10 is what? 10. So here your k or your interval is 10. So according to my example, what was the first sheet? What was the number of the first sheet that he drew? It was 3, right? So 3 plus 10, 13. So 13 is his next item. Then 13 plus 10, 23 is his next item, and so on till he gets what? 10 items in his sample. Okay, so let's have a look at, if you are confused by the procedure also, we'll have a look at an example. Now this is an example. Now here you have your population capital N as 10, so I have 10 people over here. Now my desired sample is 5, so small n is equal to 5. Now I would like to find out what is my k. Now so my k is 10 divided by 5 is equal to 2. Fine. Now the first person I pick was at random, and I luckily got that first person as 2. So 2 is selected over here. Then I know my k is also 2. So 2 plus 2 is equal to 4. Now, so the next person is 4. So I selected him. Again at 2, 6. 6 is also selected. 8 is also selected. 10. And it is more or less like a representative sample. So I have people from all walks of society over here. And yeah, and it adds up to my final number, that is 5. Okay, so this is how you perform a systematic sampling method. Now, there are also merits and demerits for this method. Now, it is very simple and convenient, and the time and effort is very less. Now, if the population is ordered according to the demerits, one of the demerits is that if the population is ordered according to the investigators, so a bias can happen. Okay, so that is all about random systematic sampling. I hope you have understood today's class. Thank you.